Hello students. So today we will see the first chapter of class 11, which is some basic concepts of chemistry. Now this first part is somewhat boring, or it would seem boring to you, but I will try to make it as interesting as possible. At the same time, we have a bonus topic at the last of this chapter, which will include your mathematical terms and unit conversion. And believe me, including that thing in your mind would help you to solve numericals very easily in physical chemistry. With this, let us start our chapter. Disclaimer: the images, text, and other material used in our presentation are for educational purposes only. We respect the intellectual property rights of the original creators and owners. If you are the owner and have any concerns or issues, please contact us at sathee@itk.ac.in and we shall remove the same. In this lecture, my objective would be to appreciate the contribution of India in the development of chemistry and understand the role of chemistry in different spheres of life. Starting from the definition of chemistry, then the very obvious definition would be that it is the science part which deals with the molecules and their transformation. Transformation means going from one element, I would not say element, I would say one compound or one material to other. But this science is not so much of 100 element, but of the infinite variety of molecule that may be built from this. Okay, you can take a numerous amount of combination and get a billion to trillion variety of molecule. So if I think about science, if I talk in the broader sense, then what is science? What we are doing in this science chapter, or you would say science subject, I would say. So we are trying to systemize our knowledge. So for that purpose, we are studying science. And in the search of this systemization or classification, so that the study can be made easier, we have divided our science into various parts like physics, chemistry, biology, and then our chemistry into further smaller parts: inorganic, organic, physical. And this division goes on to a very large scale. But this whole thing has the motivation for describing and understanding our nature. Example of curd formation from milk, okay? Or you can think of the example of vinegar formation from sugarcane juice, which is kept for a prolonged time, or rusting of iron. So these are all the examples in nature which needs the treatment of chemistry to be understood well. So as I said you, for the sake of convenience, we have divided the science subject into chemistry, physics, biology, geology, etc. As studied earlier, the branch of science that studies the preparation, properties, structure, and reaction of material substance is called as chemistry. Then, if I talk about this discipline, this chemistry discipline, it is not very old, and it is formed as a result of two very absurd things. What are those? First is philosopher's stone. So this is very interesting to just think of, although this thing is not known till date. So philosopher's stone or paras is a base metal, okay, which can convert the baser metals like iron or copper into gold. Okay, so this is a mythical stone. It has no real existence. So in search of this philosopher's stone, we have started to study a branch which is chemistry. A second thing, which is also an absurd thing, is elixir of life. So it is believed that there exists an elixir which can grant immortality to the human. In search of these two things, humans start studying different materials and their transformation. So we are seeing the transformation of iron into iron or copper into gold. So this is a kind of transformation only. And in our today's life, we are doing the transformation, but that transformation is not related to this baser metal. So can't change from one element to other. So that thing is very difficult. But we can have transformation from compound to different compound. Got it? Now, in ancient India, people do have the knowledge of scientific phenomena, and this understanding was much before the advent of modern science. Let us get to some facts to understand this thing. Starting was from the alchemy. As we have seen just now, that a stone was think of which can convert our copper and iron into gold. And this alchemy is a broader term for that transformation only. So basically, in alchemy, we try to convert one form to another. And that is the thing we do in chemistry. So it was the most primitive form of the chemistry during 1300 and 1600. And one more branch was laterochemistry. What about the modern chemistry? So this took shape in the 18th century Europe, and it was after a few centuries of the alchemist tradition. This alchemist tradition was introduced in Europe by the Arabs, and after that, the Europe shaped the new modern chemistry, which is in the 18th century. Other cultures like Chinese and Indian had their own alchemical tradition. So this mainly includes the chemical processes and techniques. So you can see that how the European world got to know about this modern science. Okay, so it was initially the alchemical tradition which was introduced to the Europe by the Arabs. Okay, which was from the Chinese and Indian tradition. Okay, if I talk about the terminology which is used in India, in the ancient India for chemistry, then it was Rasayan Shastra, Ras Tantra, Ras Kriya, or Ras Vidya. What it includes? It includes metallurgy, which is abstraction of your metal from ore, medicine, then manufacture of cosmetics, glass, and dyes. How do we come to know? So, from the excavation of Mohenjo-daro in Sindh and Harappa in Punjab, it has been proven that chemistry is very old in India as compared to the modern chemistry of the Europe, which came later in the 18th century. And archaeological findings showed that baked bricks were used in construction works, and also the mass production of pottery was seen. So you can see that how wonderful was our history. So this bricks formation is done up years ago, okay, in India, and this baked bricks were used in the Mohenjo-daro and the Harappa civilizations. Now you can think of pottery as the earliest chemical process. So what we are doing, we are trying to convert one thing into another. We are taking clay, and with the help of the machinery, we are trying to mold it and subject to heat and trying to convert it into a harder substance. So what we have done, we have changed the physical property of the clay, which was a kind of gel, to a solid structure. Okay, so this thing is a simple transformation, and this thing is also under the branch of chemistry. Now, the remains of glazed pottery was found in Mohenjo-daro, as well as gypsum cement was used in the construction work as earlier. It includes lime, sand, and traces of calcium carbonate. Then coming on to the metallurgy part, the copper metallurgy was seen in India in the Chalcolithic culture in the subcontinent. And to support that, we have archaeological evidences which shows that extraction of copper and iron were developed indigenously. So this is very, very interesting. Okay. Then coming on to our Vedas, we have the procedure of tanning of leather and dyeing of cotton. And this were practiced in the 1000 to 400 BCE. So you can see that very minute processes. Okay, so you won't see such processes in the holy scriptures, other holy scriptures, rather than in our culture. Okay, you can see that our scriptures not only include the spiritual part, but it is including the day-to-day life processes like tanning of leather, which is simply cleaning of leather, and dyeing of cotton. Okay, now here is a very interesting part. There is a golden gloss of black polished ware. So it is simply a pot, and this was found in the northern India. Okay, so this thing is very mysterious, and it is so mysterious that even with the today's technology, the structure or the material of this black polished ware could not be replicated. Okay, then our next is keen temperature, and this was keen was used to control the temperature. Our Kautilya's Arthashastra describes the production of salt from sea. So different shastra has different scientific methods for our day-to-day use. Then a vast number of statements and materials in the ancient Vedic culture can be shown to agree with this modern scientific findings. Coming on to the Raso Upanishad. So this Upanishad describes the preparation of gunpowder mixture. Okay. And some of the Tamil texts also describe the preparation of fireworks, which was made using sulfur, charcoal, saltpeter, that is potassium nitrate, mercury, and camphor. Our great scientist Nagarjuna, he was a reputed chemist and an alchemist and metallurgist. Means master in the transformation of one form to another and master in getting the metals from their ore. His works Ras Rasratnak deals with the formation of mercury compounds. Okay, so mercury compound means the uses of mercury is seen everywhere. So starting from the you can say mapping of the temperature in our body. So all of this was his work, and he also discussed the extraction of metal like gold, silver, tin, and copper. Then our next great scientist Chakrapani, he discovered the mercury sulfide and was also credited for inventing soap and mustard oil and some alkalis as ingredient for making soap. So our soap is made up of alkalis, we know it very well, and he also used some mustard oil and some alkalis as an ingredient for making soap. So India started making soaps in the end 18th century CE. Oil of Iranda and seeds of mahua plant and calcium carbonate were used for making soap. These are the material that were used. A number of classical texts like Atharvaveda in the 1000 BC mentioned the dye stuff. So now we move on to the dye stuff. So the materials that were used as a dye were your turmeric, madder, sunflower, orpiment, cochineal, and lac. Some other substances having tinting property like camplica, patanga, and jatuka. After that, Varamir's Priyat Samhita also gave reference for perfumes and cosmetics. So you can see that our science was deep into various aspects of the daily life. Like recipes of hair dyeing were made from plants like indigo and minerals like iron powder, black iron, or steel and acidic extracts of sour rice gruel. The concept that matter is ultimately made up of indivisible building blocks was appeared in India few centuries BCE as a part of philosophical speculation. And this was done by Acharya Kanda in 600 BCE, originally named by the name of Kashyapa. And he was the first proponent of the atomic theory. He formulated that very small indivisible particle were named Parmanu. Okay, this were compared to atoms. And this thing was authored in the text Vaiseshika Sutras. According to Kashyap, all the substances was made up of a smaller units called atoms. So this thing will look similar to the Dalton's atomic theory and was reported way back than the actual Dalton's atomic theory, which means atoms are eternal, indestructible, spherical, suppressible, and in motion on the original state. So you can see that very unique properties of the atoms were already been defined. So although some are not true, like the indestructible part and all, but still the motion in its original state or the spherical part are very exclusive and significant points. Then he explained that this individual entity cannot be sensed through any human organ. After that, Kanda added that there are varieties of atoms and different atoms were for different classes of substances. So this is also a direct point from the Dalton's atomic theory. Parmanu or the word atom come from pairs or triplets. Among other combination and unseen forces cause interaction between them. So he conceptualized this theory in 2500 year, around 2500 year, and it was way before the John Dalton. Then Charaka Samhita is the oldest Ayurvedic epic of India. So now we are coming to the medicinal part, and it describes the treatment of diseases. Like the concept of nanotechnology, which is reduction of the particle size of metal, was also discussed in this Charaka Samhita. And Charaka Samhita said the use of bhasma of metals in the treatment of ailments. But as the modern science crawled, the decline of alchemy, electrochemistry, and the Ayurveda started to fall. Okay. And then the practice of Western medicinal system existed in the 20th century. So during this period of stagnation, the pharmaceutical industry, which was based on Ayurveda, they continued to exist, but they gradually declined. Okay, so their existence was vanished. It took about 100 to 150 years for Indians to learn and adopt this new technique. During this time, foreign products poured in. So you can see that how slowly and silently the Western practice of medicine crawled into India, and destroyed the Ayurvedic system, which was already there in existence way before the Western medicinal practices. Now, as a result of this, indigenous traditional technique gradually declined. Your modern science appeared in the Indian scene in the latter part of the 19th century. And by the mid 19th century, European scientists started coming to India and modern chemistry started growing. So now we will see how slowly the modern chemistry started growing in India. So from the above discussion, we have learned that chemistry deals with the composition, structure, properties, interaction of matter, and is of much use to the human being in our daily life. Now coming on to the modern science, so it plays a modern chemistry. It plays a central role in science and is often intertwined with other branches of the science. Like principles of chemistry are applicable in diverse areas, whether the weather patterns or your functioning of brain, operation of computer, production in the chemical industries, manufacturing fertilizers, alkalis, acids, salts, dyes, polymers, drugs, soaps, detergents, metals, alloys, etc. So you would see that almost all of those things are as a part of chemistry and including all the new materials also. So you can say that chemistry contributes in a very big way to the national economy. Then it plays a very important role in meeting human needs for food, as the insecticides and pesticides are being produced with the help of chemistry, and the healthcare products and other materials aimed at improving the quality of life. Examples of this are, as I discussed, as I have told you now, fertilizers, pesticides, and insecticides. Then, chemistry provides method for the isolation of life-saving drugs from natural sources and makes possible synthesis of such drugs. So, you can think of the Kencona bark, which is used in the treatment of malaria. Then, if I talk about the latest discovery, then this cisplatin is used in the treatment of cancer, and Taxol also is used along with this cisplatin. Then, in the recent years, the chemistry has helped in dealing with some pressuring aspects of environmental degradation with the help with the fair degree of success. How? So we have seen that now we are using the renewable sources of energy instead of the non-renewable sources like fuels and the say coal. Okay. So this safer alternatives to our hazardous refrigerants like CFCs are which were responsible for the ozone depletion are been successfully synthesized. But one such problem is the management of greenhouse gases like methane, carbon dioxide is still a problem. Then, understanding of biochemical processes, use of enzyme for large production of chemicals, and synthesis of new exotic material are some of the intellectual challenges for future generation of chemists. What is the meaning of this sentence? So, enzymes are much more effective than the catalysts that we used in our industries earlier, and they are very efficient and specific for the thing for which they are used. This makes our production thing very fast. So a developing country like India needs talented and creative chemists for accepting such challenges. So to be a good chemist and to accept such challenges, one should understand the basic concepts of chemistry. And with this, we will begin the concept of matter in the next class. Okay, so this was all about the build-up of the whole chemistry that we will see. So just you can go back to the previous slides and try to appreciate what India has done and what the modern science has done to enhance the standard of life. Now, this all was a part of the chemistry. But we will see in the later on chapters that mathematics has a very important role to play, and students face difficulty, especially who are practicing it for NEET or who have opt for NEET, face difficulty in this area. For that, I have put up some tools here so that you can say remove all these obstacles and attempt the mathematical questions as well. First is your log property. Okay, so starting from the product property, if you have suppose ln. So what is ln? First of all, you don't have to learn how to use the log table, because in the recent days I have seen that in most of the question papers the value of the lns are already given. But you need to deal with the basic mathematics or basic arithmetic rules related to this ln. Suppose starting from the product property, what does it say? Suppose we have ln. Ln is natural log and log is logarithm. They do have a relation. We will see it later. So if you have ln ab, so we have ln, and inside ln we have to take the products of a and b. This thing can be written as ln a plus ln b. So suppose ln, then in the bracket 2 into 3, then you can write it as ln2 plus ln3. Remember, this 2 into 3 are a part of ln. We have to take the ln of the whole product. Similarly, if I talk about the quotient property, then ln a by b can be written as ln a minus ln b. So multiplication means addition and division means subtraction. Third property, very, very important. If your m, which is a whose ln you have to take, has a power as p, then you can take it back here. So suppose it is written that ln2 to the power 3, then you can write it as 3 ln2. So here p ln m. Then next thing, e to the power ln x is simply x. Very simple. Remember this. After that, ln ex is equals to x. So this is the thing for ln. Remember, x should be greater than 0, then and then only. Then this is a very common property. We have studied it earlier also. E to the power x, e to the power y. That means x is equals to y. But why I have written it here? So if it is true, then ln x is equals to ln y means that x is also equals to y. Now, a very important thing. What does this ln mean? Or what does this log mean? So if you are saying log 100, it means that what power of 10 you will take so that your value become equals to 100. So it's very simple. 10 to the power 2, that means ln 100 has a value of 2. Isn't it? Very easy to understand. How you can solve it? So not ln, it is log. So if you are taking log 100, then its value will be 2. How you can think of it? So what we can write? Instead of log 100, we can write log 10 to the power 2. And using the property of ln, so all of the properties of ln are applied to log also, except this one, okay, these two, because it is related to e. So if you have log 10 to the power 2, you can write 2 log 10, and log 10 value is 1. Okay, log 10 value is 1. Similarly, ln e value is 1. With that thing only we have written this, because now it is ln e to the power x. So you can write x ln e using this property, ln e equals to 1. Therefore, ln e to the power x is equals to x. I hope you are getting my point. Now, what is the relation between ln and log? So if you are given that ln x, then you can write it as 2.303 multiplied by log x. As simple as that. So I have told you earlier that what does log 100 means? Log 100 means that what power of 10 you will take so that it becomes equals to 100. So it obviously 2. So log 100 is equals to 2. When we talk about ln, we think about the power of e. Okay, we think about the power of e. So if I am saying that ln 100, then it means that what power of e you would take so that you get 100 as the value. So simple. If you are dealing with log, then think about 10. If you are dealing with ln, think about e. Maybe this base 10 or e can be changed. It will be written in your question that okay, log 10x, or you can write it as logs 100x. So that is a different thing. So you just have to change the 10 part. Clear? I hope you are getting these properties. So these are very, very important. Just take a screenshot if you want. It will help you in your whole mathematics part. Then moving on to some differentiation formulas. First is the differentiation of a constant is always 0. Constant means any number 2, 3, 4, 5, 6, 100, any number whose value is fixed. Okay, or any other constant whose values are not changing will be always 0. Then, and again, one more important thing, its value is constant with respect to x. Okay, so suppose if a body is moving along y direction, okay, or if it is changing the coordinates of y direction, then what is the change of the body or the change of the position of the body with respect to x direction? It is 0. So the change will be equal to 0. So remember this thing also. It is also very important to think of. So we are trying to say that your k should not change if we change the x. Clear? Next thing, if you are taking the same thing upon here and here, then it will give you 1. Again, think of the physical part. So if you are changing 2 to 3, okay, then what is the change? It is 1. And here also you are changing 2 to 3, in the downward also. So both will be equals to 1. So their rate will be same. Okay. Suppose I ask you, what is your rate of change of years with respect to the years? So which each year you are changing it by 1. Okay, your age is getting enhanced by 1. Similar to that. Then if you have a constant, suppose, then this constant will go outside and dx by dx will give you k. So you never do a differentiation of the constant. For that reason, we have taken this constant out. This will be done in the case of multiplication with a variable. So if you have a variable multiplied by the constant, then only we'll use this property. If it is alone, then it will be 0. It says in the starting first point. Now suppose your x here now has a power of n. Then what you will do? It will be simply nx n to the power and nx to the power n minus 1. You can try it by yourself by taking any power and getting the differentiation answer. This is a very important property. d e to the power x is equals to e to the power x. Okay, so this is very, very important. Coming on to the next property, if you take it for the ln x, then d of ln x will be 1 by x. So these two properties are somewhat unique. So you should remember these two specifically. Now coming on to the, say, trigonometric part. So the differentiation of sin x is cos x. Cos x will be minus sin x. Okay. And for tan x, it will be sec square x. So remember all of this. Cot x will be minus cos x square x. And I hope you are already aware about this sin x cos x in the 10th standard only. Then the differentiation of sec x is equals to sec x into tan x. So I will suggest you to remember all these formulas which I am showing you in the mathematical part. Our last formula is about cosec x, which will give you minus cosec x into cot x. Then moving on to the integration. Integration of x to the power n will give you x to the power n plus 1 by n plus 1. Okay. So this is opposite of differentiation. Just go back to the formula and try to compare it. But this n should not be equals to minus 1. Okay. It should never be equals to minus 1. If it is minus 1, then our thing will become ln x. Remember, we have a constant also plus x, but I have not inscribed it here. Okay. So this constant is coming here because if you do the differentiation, then that constant is removed. But if you do the integration, you will never know what the constant was. So suppose our equation is 3x plus 1. If you do the differentiation, you will get 3, but that 1 will be removed. And if you do the integration again of that 3, you will get 3x, but that 1 is not there. So for that, we take plus c after each integration in case it doesn't have a limit. Similarly, for ex, the integration is also ex because the differentiation is e to the power x is e to the power x. So for integration also, we have the same thing. For sin x integration, we have minus cos x. For cos x integration, we have sin x. So remember the differentiation of cos x was minus sin x. So the integration of sin x is minus cos x. Similarly, integration of cos x gives sin x. Just opposite of the differentiation, okay? And they will have plus c here. Sec square x will give you tan x. Cosec square x will give you cot x. And sec x into tan x will give you sec x. And lastly, cosec x into cot x will give you minus cos x. So this minus is coming from the differentiation of cosec x, which was giving minus cos x into cot x. And remember, each of this will have a constant as plus c, since they don't have a limit. If they have a limit, we will not put that plus c there. Now, a very important thing in chemistry is the unit conversion. Why it is important? Because you are given the question in different units and the answer always is asked in the different unit. How I will convert it? So first is for the pressure. If you want to convert 1 atm into mm of Hg, just multiply that thing by 760. So if you have 2 atm multiplied by the 760, you will get the thing in mm of Hg. If you want to convert this atm or atmospheric pressure into torr multiplied by 760, then you will get the torr also. Both are the same thing. Means 1 torr is equals to 1 mm of Hg. But 1 atm is equals to 101,325 Pascal. Okay. With the help of these two relation, okay, atm and mm of Hg and atm and Pascal, you can find the relation between mm of Hg and Pascal. Just try to do it by yourself. Okay, and get the answer. Then talking about the energy, so 1 joule is equals to 3.6 into 10 to the power 6 joule. Not joule. 1 joule is equals to 3.6 into 10 to the power 6 kilowatt. So this is conversion of kilowatt hour into joule. So if you take 1 kilowatt hour, then it will conclude to 3.6 into 10 to the power 6 joule. Similarly, if you take 1 calorie, it will have 4.184 joule. So to convert 1 calorie into joule, you will multiply that thing by 4.184. And similarly, if you want to convert electron volt, you will multiply this thing by 1.6 into 10 to the power minus 19 for the joule conversion. So if you have 1 electron volt, you will have 1.6 into 10 to the power minus 19 joule. If you have 2 electron volt, you will have 2 into 1.6 into 10 to the power minus 19 joule. Got it? And our last and most important thing is the unit prefixes. So if you are given, suppose 1 meter, then how many picometer will be there in 1 meter? 10 to the power minus 12. From here questions are asked, okay? Then nano 10 to the power minus 9, micro 10 to the power minus 6. If I talk about the most important one in terms of structure of atom, then these three are very important. One more, angstrom is there, which is 10 to the power minus 10. Coming on to the larger one, which is kilo and mega. So mega is 10 to the power 6 and kilo is 10 to the power 3. And then we have also milli, centi, deci, deca and hecto. So these are also very important. Just try to remember all of them. So this was all about the theory part. Thank you.